Good to go? Okay. Okay. Hi guys, my name's Nate Power. I'm a senior security engineer working on the FUFA security team over at CDW. A lot of what I'm going to be talking about to you guys today is several information disclosure vulnerabilities that I actually found in the OWA. And really what I'm trying to do here today is really just push this information out there. I have been working with Microsoft over the last year or so, trying to get them to actually patch some of these issues, and they're pretty much just not doing it. To where I think you guys will I'm going to show you today how serious these are and how I'm actually been leveraging these on a pen test. For those of you who don't know, an OWA is actually a service that runs on a client access server. Client access server is basically communicates to backend exchange systems and Active Directory. It's usually exposed to the internet, so end users can get their webmail remotely. And a lot of the information disclosures I'll be discussing today will give us information about the internal network, backend Active Directory setups, and we'll even talk about better methods to be able to extract Active Directory credentials. Okay, so some of the things we have on the agenda today. Sorry, I don't have this displayed right here on my laptop. I'm going to be looking back this way a little bit. We're going to be talking about some discovery methods that I've been using to be able to find a client access server on the internet. We'll talk about ways to actually be able to validate users without actually authenticating to the system. We'll be discussing some issues I found in the Autodiscover service and how I've been leveraging those on a pen test. Then we'll talk about a few methods that we could do to actually reduce some risks. Okay, so discovery. Okay, so the client access server has actually been around since OWA 2007, and it goes all the way through 2013. Initially, when the OWA 2007 came out, there was no client access server for it, and I would consider that version 1, and then there was a version 2 to where they actually supplied client access server support for it. Evaluating Outlook client communications when it's actually trying to use the Autodiscover service to find it on the internet. I'd kind of man in the middle of the traffic to see what was going on there, and I'd found out that the Outlook client is doing a series of static URL lookups along with a DNS service lookup to try to find the address to the client access server. I had taken a sample size of 500 domains. I had taken those two discovery methods that the Outlook client was using along with several common pen tester methods, and I'd actually found that the static URLs were the most common method to be able to discover the client access servers, to where DNS brooding came in second, evaluating SSL certificates came in third, and then the DNS service record was the least utilized. Okay, so this is actually the very first issue I found in the OWA. It was actually in an OWA 2010 Forefront TMG setup, and when you attempt to go to that URL path and trigger the ASP.NET debug, I'd found that an overly verbose error message was being revealed, and it was actually coughing up the internal address to the reverse proxy handling the request. And I found this to not necessarily be specific to Forefront TMG setup, to where I've seen third-party reverse proxies have the same behavior. I had found a method to be able to reveal internal IP addresses of the client access server, to where I found this on OWA 2003, along with 2007, 10, 13. And essentially what I'm doing here is I'm actually sending a GET request, a very specific IIS file path, and if I use an empty host header in my request, where on a 302 location or the 401 basic realm headers actually return back the internal IP address of the client access server. And I do have a Metasploit module out there. It's not officially been submitted to Rapid7, but it is out there on the fufus.net website. Here's the vulnerable paths that I found. There are several other ones out there that are included in the Metasploit module. Some of these out of the box, they'll have things like basic authentication already enabled by default. Other ones, you'll see maybe a sysadmin had came in and enabled basic authentication that's making them actually vulnerable. Okay, I got a demo for you guys here. Oh, shit. Hopefully you guys can see that okay. So I'd basically written a pretty dumb shell script that goes through this discovery phase. And with this video here, I just want to kind of show you guys how easy it is for me to discover client access servers on the internet. It's a video. This is the best I could do. So I had input the domain example.com. I had found the static URL pass to the Autodiscover service. Had found some results with DNS rooting and evaluating the SSL certs. Okay. In this video demo, Okay, I'm actually utilizing the OpenSSL client in Linux to be able to manually find the internal IP addresses of these systems. I kind of just wanted to show you guys how I'm doing this manually, because if you're ever doing a web app, this can come in handy and it's real quick and easy. So I had initially connected to the Autodiscover service, and I'm just doing a GET request, but the host header here, I'm just making it pwned. Then I'm accessing the Autodiscover service path that's vulnerable. I wanted to show you guys in the returning header for the basic auth, we have pwned in the realm. Now if I remove the host and I just put the file path, the actual internal address is revealed in the basic auth header. Okay, so I had actually found a way to be able to validate Active Directory accounts that exist, and I had initially done this through a timing attack. I was actually working a pen test, very limited time, and I was attempting to brute force credentials out of the system, and it was actually a Forefront TMG OWA 2010 setup, and I had it seemed like all my authentication requests were taking about a minute. I had 19,000 usernames I was attempting to go through, very limited time on the project. I was actually had inserted this code here to try to determine down to the second how fucking long is this going to take me to be able to go through my list of 19,000 usernames. Well, in doing this, I actually had discovered patterns that existed in the response times of the authentication requests. I had found that the way that the client access server actually communicates to the domain controller, that the Kerberos process is actually staged in such a way to where the client access server first initially looks for the actual domain to see if that exists. If that domain exists, it'll actually search the database to see if the account or the username exists. Then, of course, it'll try to validate the password after that. Here's some of my results from my testing. So I had found with non-existent domains, when you're sending authentication requests and the domain doesn't exist, the response times were taking anywhere between 2 and 3 seconds. When the domain exists but the username doesn't exist, I had actually found that the response times vary between systems, but there's a pattern there to where it's a consistent response time. And then, of course, if the domain exists and the username exists, the response times were coming in under 2 seconds, but I'd say most of the time it's underneath 1 second. And a lot of the response times really depend on things like system resources and network latency. Doing a timing analysis on domains that don't exist. In the middle column there, that's actually my username list I'm trying to brute force. I had seen that the very first authentication request would come in 2.25 seconds, and then it seemed like every request after that was coming in underneath 1 second. Well, continuing to let your brute force move forward, it seemed like every 30 seconds I'd see the 2.25 response time again. And then again, it would you just see the pattern of all the requests underneath that coming back under a second. Okay, doing a timing analysis when we actually know the Active Directory domain. In this case here, for accounts that didn't exist, the response times were on average 15 seconds. And then response times for accounts that actually valid, they're coming back in underneath the second. And it actually doesn't matter if the account's enabled or disabled. The timing attack will actually tell you if the account exists in Active Directory. Here's all the vulnerable paths that I found on the timing attack. Form-based authentications pretty much broke. Then I'd actually found some static IS file paths here that support HTTP over NTLM are vulnerable. And again, there is a Metasploit module for the form-based authentication out there on foofus.net. Okay. So I'm going to take you guys through a little bit of a scenario here. Okay. So whenever I'm trying to evaluate if the timing attack works or not, I'm on purpose building a username list of accounts that I know for sure doesn't exist in their Active Directory, and that I'm using some default accounts like administrator and guest just to verify that this attack works. I'm going to speed it up here a little bit. This process is multi-threadable, though. This is just pretty much proof of concept. Okay, so we had C here, we have administrator. Came back underneath 1 second. You guys are looking here. Then the accounts that didn't exist are coming back in 15 seconds. So we know the timing attack works. So the next thing I'd do on a pen test is actually throw a list of usernames in there of common accounts. And at the very top left there, you can see I have common accounts such as backup, help desk, HR, SQL service, training, and webmaster. Because the goal here is to actually build a list of usernames that we know exist in Active Directory. Okay, so ran through our list. We're actually using a password to password one, and we got lucky as shit. We see that the SQL service account exists and the training account exists, but we actually had a successful login on that. Well, what can we do with it now? We can try to log into the OWA, pull the global address book, and we'll have all the accounts and everything in Active Directory. Okay, here we go. Okay, we try to log in with the training account. Whatever, it logs in. And we actually found out this account's not set up in Exchange at all, to where it doesn't have any mailbox permissions. We won't be able to access the global address book since it doesn't have a mailbox and not set up in an Exchange. Ran into this issue several times, but I found some issues in the Autodiscover service where we can still leverage this account. Actually written a tool for you guys for this. Basically, you don't need any Exchange permissions or a mailbox to be able to authenticate to the Autodiscover service. Then I actually found an XML SOAP parameter injection in the service that allowed us to enumerate autodiscover.xml files for other users that actually existed in Exchange. This is a SOAP request that a remote Outlook client would actually send to the Autodiscover service. The email address parameter is actually vulnerable here, and if we input a valid email address, we're actually able to extract that user's Autodiscover config. Some of the things we're actually seeing in the config, we got users' full names. We actually have Exchange permissions, and by default everybody's set up into the Exchange administrator group. But I would consider that group more of a container, and there's objects within that group that are actually divvying up the permissions. If you have ever migrated your Exchange environment, and if your company's been around for a while, I'm sure you have, there's legacy DN information that's getting stored into the Autodiscover config that's actually revealing usernames and username formats. We have domain controllers that user would be able to authenticate to from the client access server. And then we have the service URL pass and permissions that user has actual access to on the client access server. And I would say here, running through and just enumerating a shit ton of Autodiscover configs. I think it's interesting though, because in some cases I actually see sysadmins messing up permissions, and you'll actually see not every user necessarily authenticates to the same domain controller. So where the domain controllers are helping us build information about the internal network and maybe the naming conventions of their servers. Okay, this might be hard to see, but this is the ADIS-enum tool that I wrote. It's out there on foofus.net. Pretty easy to use. Obviously need valid Active Directory credentials. Let's see. So everything here is actual legacy DN information, and these are usernames. Let's see. We have the actual domain controllers down here, and we have the display name. So kind of going back to my other scenario of trying to extract Active Directory credentials, we can, now that I know the username formats, I can actually build my own list of A numbers and try to validate those users to see which ones exist in Active Directory. Okay, so very top left there, I generated my own list of potential usernames using the Metasploit module to be able to run through these and figure out which ones are actually valid. And we're still using a password one. Let's speed this up. Okay, so we can see here A0341 was valid, A0344 was valid, and then we had 4 more on the bottom there that are actually valid accounts in Active Directory. So now we can go back and actually, now that we have a list of valid users, we can go back and try to do our password guessing. Okay, and you can see I have all the valid A numbers, and I actually have the SQL service account where we need those credentials still. And we're using a password December 14 this time. I just want you guys to see how quick this process has gotten now that all the requests are coming back underneath the second. Metasploit takes a minute to load. So, and then you saw how quick it took us to be able to brute those. And we had actually had 2 successful logins. Okay, so what can we do to actually reduce risk? So the reverse proxy internal address getting revealed, Microsoft had actually fixed that one, so you guys would just need to apply that. I would disable anything basic author through 302 redirects, so your internal addresses aren't being revealed to the client access server. I think the Autodiscover service is a complete piece of shit, and I'd completely disable that altogether. I'm not seeing the timing attack actually in anything ISA, Federation Services, or even Outlook.com. But it is pretty interesting, though. I started to see more and more customers migrate over to Outlook.com, but they're still leaving a client access server on the internet just for the Autodiscover service. And then lastly here, I would, you guys monitor your backend domain controllers. By default, the domain controllers are only logging locked out accounts to where the log level actually needs to be kicked up to log failed accounts. To where if you're monitoring the behavior and you're seeing so many failed logins in a certain amount of time, you'll actually be able to determine when your client access server might be under attack. Okay, so I actually have advisories that was released August this year. They can be found out at fufus.net or my blog, securitypentest.com. I'll leave this screen up for a minute if anybody wants to write down this URL. I basically have the internal IP address tool, timing attack metasploit module tool out there, and the Autodiscover enumeration tool is out there on the fufus.net website. Does anybody have any questions? I was having trouble hearing them. I don't know. I should probably do that, right? Okay. Anybody else? Okay, that's all I got, guys.